Let's look at some fun addition in geometry. Okay, so let's look at two lines, this one and this one on the top and the bottom, and each one has 3 points. Two adjacent points and the bottom two adjacent points have crossing lines. And with the next two adjacent points here and here. Now, in these crossing lines, we've drawn a line that goes right through the crossings. Okay, these 3 lines put together make up something which we will call a cubic. Not quite like an elliptic curve, which has a fun addition, but nonetheless, it shares a lot of the same properties. You can add points, but not every 2 points you can add, but some points you can add. And just like with elliptic curve addition, this addition is associative, even though it's not always defined. So it doesn't make up a nice structure like a group or anything. However, it's a partially defined addition and it's associative. How can it help us? Well, let's see how it might work. If we want to add 2 points together, we need an anchor. This is in place of the point at infinity in an elliptic curve. We just pick another point to be an anchor. Now, even with elliptic curves, elliptic curve addition still works just fine if you choose another anchor as well. You can still define an addition on an elliptic curve that way, as you can here. But here we just pick a point. Let's just pick the point O as our anchor. Now, what if we wanted to add A plus B? So what we would do is we take A and B, find the third point, find the third crossing of this red line with the 3 green lines, which is right here. Find the third crossing. And then what we do is we take that third crossing with the anchor point, and that makes a line. And where does that also cross? Where does that cross the 3 green lines? The 3 green lines is kind of like our curve in some sense. And we have 2 crossings, and where does it cross the third time? It crosses right here at Q. Okay, so that actually serves as our vertical partner type idea. So we find the third point on the line between A and B, and we take that point and find the third point of this line between the anchor and that point. And that replaces taking the vertical partner. So we have A plus B is actually equal to Q. All right. Let's also do B plus C. What is B plus C? Okay. So let's take a look and think for a minute about what we can do. We take B and C, we take the third point right here, and right here, and we look at where that has a line with the anchor, O, and we look at the third intersection between this red line and the 3 green lines, which is T. So T would be the sum. It's like the vertical partner. So that's T. All right. Okay. Now what we're going to do is let's think about associativity. How does that help us here? And what kind of geometric result does associativity give us in this situation? Well, let's see. We have A plus T now. So A plus T, we might have to draw a line going like this. All right, and it's going to cross right here. Okay. And then we would have to go through and find a vertical partner and go for it. But notice that this point right here really determines what the sum is, because we draw a line from here to here between O, and we get a point. So this means, you see, but this is kind of like the place right before I get the sum, like right before I take the vertical partner, that uniquely determines the sum. Okay, so, and we just did this one right here, A plus quantity B plus C. We should get the exact same results since we have associativity. We should end at the same point if we did the other addition. Let's see what that does for us. So this is Q. So let's take Q and draw a line from Q to C. All right, where does it cross the green line? Well, the third point, remember that the third point here, the crossing actually determines what the sum is. And so it should be the same as this one. So they cross. So wait a minute. The line from here to here and here to here actually cross on this green line as well. That's the geometric result. So if I draw 3 lines over here and 3 lines over here, cross, cross, draw a line through, I know for sure that this line and this line will cross. This result is really cool because it doesn't just apply for 3 lines. It applies for anything that can be considered in geometry as a cubic. Think for a minute. A line is linear, 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 and together 3 lines we're going to call a cubic. What other situations could we have? Well, why don't we do something like this? Why don't we have an ellipse? And maybe a line, and we can make a line passing through it using the same basic idea. Pick any 6 points on the ellipse that you want in any particular location. And then you can cross lines and cross lines again. Draw a line through right here. And the same type of argument will show that if I draw a line from this point over to this point, and then, so let me see, let's do that with red. So if I draw a line from this one and a line from this one, if I've drawn my ellipse appropriately, it should cross on this line. And that's what we've just shown. We've just shown this fun geometric result, and it comes because of associativity, of this addition on this cubic shape, which is a lot like the addition on an ellipse. Now keep in mind, this addition is not a group. However, it is associative.